don't know if you're already back at the computer. If you are, I would start this session. Okay, so we start now with that session. Well, this morning, or rather this session. Wait a bit. Now we have the others joining us. So good morning. Waiting for everybody's audio. So good morning, good afternoon. Starting into this session today, or rather this block here. It's me because Alexander is the one who had to step out for some other stuff. Seems to be a busy week. And of course, well, as you noticed, I didn't make it back in time yesterday to actually see where you left off. I think Alexander got you up to the point where, well, he introduced the exercise to add the second client, to add another client, probably with some hints that you will have to do not just bacula administrator work, but general system administration as well, installing software, making sure network addresses are aligned, thinking about firewalling. All those things are necessarily part of a client deployment for good reasons, I dare say. But now that we have essentially introduced how you increase or how you grow your backup environment by adding clients, we need to have a closer look at the storage end. Where we have up to this point, or you have up to this point, just used what was pre-configured storage daemon with storage devices, which just worked, and we will now look into all those well considerations that that we need to be aware of if it actually should work and work in the way we want it. So looking into things, that means, of course, we're looking at the storage daemon. We will start with the usual kind of review of the very basics for the storage daemon configuration, where of course the storage daemon itself is one of those processes running somewhere in your infrastructure. Usually that is coming back to something that was mentioned very early in this course. Usually you will have at least one storage daemon. Very often it's a few more, but there will not be too many in most cases. Each storage daemon needs a configuration to, well, as the usual stuff with the bacula daemons is, to understand who itself is. it needs a name. It needs to be configured to listen to the network. The defaults we have do apply, but you can change that, of course. Storage daemon also needs some additional configuration. It needs room to put some temporary data and all those other things. And one of those other things is, of course, our favorite maximum concurrent job setting for the storage daemon global. This is really the basics. We will look into more options and more details here. First, let's look at the network side, and of course, that can be interesting and important also for reasons of security. In many environments, you probably find that you have a dedicated network for backup purposes, separated from the production network, typically separated so that it is not accessible from the internet at large or from your workstations or whatever it is. And if you want the storage daemon to only bind to that network, of course, you will have to configure that accordingly. We have the SD address setting for that purpose, which needs or gets an IP version 4 address. The default, if you do not set that, is that the storage daemon will bind to all IPv4 interfaces it finds on the host it runs on. You can, for the network address, for the SD address, you can also use a fully qualified domain name. Actually, you could use a plain domain name as well. The effect would be that the storage daemon on startup looks up the IP addresses belonging to that domain name and would use the first one it finds to bind to. And that is very often not what you want to do. If you're using this sort of control over who can access the storage daemon, it is best to actually put the numeric IP address here. Essentially the same thing you configure in your network interface settings. And by the way, one thing we do not look at in detail here is if you want to bind to more than one address or potentially use IPv6, we have a different setting you need to use. It's a bit more complex then, of course. So besides the address, the storage daemon will need to listen on a particular port number. The default for the storage daemon is 9103 from the number range you have seen introduced before. That is, as usual for us, the usual IANA assigned port number. That is, of course, pretty reasonable to use this default and to not change it. If you need to change that, we have the SD port configuration setting for that. And of course, this number needs to be changed accordingly on the director side, where we control how to access the storage daemon for actual running things. So there is no good reason to change the default, unless, and that is really rarely the case, unless, of course, you need to have more than one storage daemon on one host system running, in which case you will have to change either addresses or port numbers, which in my working environment typically only happens for our developers when they run test instances for regression testing, for QA, for example. In actual production instances, it is very rarely necessary or useful to change the port number. One of the advantages of using those IANA assigned numbers is that the documentation is essentially implied in your services file, that your colleagues responsible for network management will have no problem understanding what service that is they are configuring implicitly with their firewall settings, for example. So the advice we give here is, of course, to stick with the defaults. So, and then network related, we also have this heartbeat interval setting, which you already heard about in different contexts. We have this same setting, of course, for the storage daemon, its global configuration. The effect is the same thing. When the storage daemon runs with this configuration, it would, for any connection it has opened, it would, if there's no traffic actually, or no production traffic, or bacula protocol traffic going on, it would send, in a way, dummy or ping packages around this connection with the interval that you configure here. And it will also, by the way, always reply to incoming such heartbeat packages. This is really complementary. In very rare cases, will the storage daemon open its own connections? That happens only with particular configuration for specific jobs with specific clients. So responding to incoming messages is something the storage daemon would be doing anyway. And here we can control that it uses that same facility for its connections that it creates outgoing. The reasoning here is something Alexander surely explained. We may have connections that need to remain open, but where no big traffic is going on. And we need to make sure that any sort of network equipment in between the endpoints, routers, firewalls, can remain aware of the fact that this is a legally opened and just idling connection, and they don't kill that one. So this is a bit of the network stuff. We have some more things, the timeouts and the network buffer sizes, also something that has come up before. Here, the client connect timeout, that is actually quite important in many cases. We have a default here of 30 minutes, and that is the time the storage daemon waits for an incoming connection from a file daemon from a client after the director has announced such a job to happen. Well, we need this. Of course, waiting indefinitely forever is never a good choice. So we have to have some sort of timeout here. Otherwise, we would be pretty inviting to problems due to network issues, for example. But we would also pretty inviting to problems due to attacks. So essentially, some sort of here at this case, application level denial of service attacks, which we need to avoid, of course. The hopefully more important reason we need this is that while the storage daemon waits for a client to come in to actually start doing something, the storage daemon already has reserved some resources for the prepared job. In particular, a device, a drive, will be reserved, and a volume will be locked because that all those things happen right at the beginning when the storage daemon and the director start a job. They do that more or less jointly, and once that is done, the storage daemon waits for the client, but it has resources reserved. Well, waiting too long means we are blocking resources which could be allocated more usefully to things that actually happen. We have this rather long time out here because we believe that there will be rarely situations where we actually run into problems here. If there are problems, it is very often that's our assumption, related to issues in your internal networking or in the client side, edge network, border network boundaries. And the assumption is that those problems will be noticed pretty quickly and they will be fixed pretty quickly. So we can afford a long delay, essentially trusting that if there is ever any delay, it will be fixed and we do not have to cancel initiated jobs and you do not have to restart them manually in the end. If you find that you actually see jobs failing at this state, then most of the time you will probably have to think about the reasons here, and you will have to tackle the problem at the at that level. It should be rarely necessary to increase that wait time or this client connect timeout. It may be useful sometimes to shorten it, in particular if you're doing lots of backups, for example, with external hosts, like for example laptops that your colleagues carry around and at home or in hotels. where all sorts of connectivity issues might exist. If that is the common use case with your bacula instances, it might be useful to shorten that, because you will have you will just wait less time waiting. Shouldn't be happening too often, I think. And then we have this maximum network buffer size setting, which is the complementary, the opposite setting to the configuration item with the same name on the file daemon side, which Alexander probably introduced yesterday. Which should be rarely needed by default when the bacula components start TCP streams between endpoints. Well, they do nothing special. They just use the application or the library and the TCP stack and the operating system defaults for those things. In some cases, you may have to adjust this buffer size. Essentially, that's more like the application side of the send and receive windows of the TCP/IP stack. Which means, first of all, this is very, very platform specific, what it actually means and what it does. And secondly, it's also something which needs to be correspondingly configured on the operating level side. You will probably need to touch those settings only if you are experiencing problems. We have seen that a very long time ago that a certain family of Windows network drivers had problems with the defaults, but that's really decades ago, I think. And we see this occasionally being adjusted for situations where you have which is also quite common. You find that you're not making best use of your network capacity for high throughput and high latency links, which is the usual wide area network links with really high throughput, such as you are seeing them occasionally in the backbone networks of large data center operators who are actually running fiber networks between data centers on different continents, for example. To actually saturate those links, you probably need to increase the buffer sizes and accordingly. And again, of course, you also need to make sure that the operating system level TCP/IP settings are configured accordingly. You would have to think about receive and send window sizes and the backup strategies of your TCP stack, complementing those things with the maximum network buffer size setting here on the bacula end is usually the last step you would be doing. And if you are working on those things, if you have to do this sort of fine tuning of tweaking, I hope that you are working either because you know about that yourself, or you have experts working on your side responsible for the network stuff, because this is usually very, very specific and needs quite a bit of configuration on all involved routers and switches and firewalls in between as well. Trying to tune for best network throughput at the application level is usually not the most reasonable approach. However, if you need to do that eventually at the bacula level, you can do that. And this setting, maximum network buffer size setting, would be essentially the only thing you can really tune. It is only relevant also for the communication between the file daemon and the storage daemon, because that is the connection where we actually see bulk data transfers happening. The other connections from director to storage daemon, they are mostly control traffic. No big amounts of data transferred there. And even more extreme, it is for the connection between the director and the file daemon, where essentially the director only sends usually a very short set of commands to do anything. Sometimes we have a spike of data transfer there when the director sends what we call the accurate information, essentially the list of all the files that were already known to be backed up from that client. But after that, this connection sits idle and doesn't do anything at all until the actual data transfer between storage daemon and file daemon has finished. And then we just have the file daemon checking in with the director with a very short status report on the job. So this is not a connection where you can expect ongoing large amount of data to be transferred. So this setting is very special, very particular. Sometimes it's important, and most of the time you will not have to think about it at all, which is well, the way it should be, essentially. So, and then we have, of course, our aforementioned favorite topic, job concurrency. We can have maximum concurrent job setting for the storage daemon globally. Keep in mind, we're talking about the storage daemons configuration affecting everything one particular running storage daemon would do. And we have the default here being 20, which means a storage daemon by default will be able to run a maximum of 20 jobs at the same time. You should be aware that if you want the director to be able to query the storage daemon for its status, just to check in, what are you doing with the status storage command that you would be issuing in bconsole, for example, that counts as a job at that level. So if you want to be able to do that and actually run 20 backup jobs, of course, that would mean you have to set maximum concurrent jobs equals 21. Now, our recommendation here is that you should have a setting here which is rather high. It should be more, again, like the last resort limit to avoid denial of service or resource exhaustion problems, because there are better ways to actually control and set the limits that you need to enforce, that you need to see. There are two reasons for that. One reason is that the number of jobs that run to any particular storage device that this storage daemon configured here has may be needing a bit more granularity. For example, you might have devices allowing just one job at the same time, while other devices are probably configured to run more than one job at the same time, and you do not know how the device usage actually is expected to develop over time. So sometimes there you will probably need more jobs running at the same time, while at other times you want less jobs running at the same time, and you of course cannot represent that with the global configuration. The other reason is that the changes of the storage daemon configuration would require you to restart the storage daemon. And restarting the storage daemon would implicitly abort everything that is currently running. So a backup job that is currently running will be well, broken when you restart the storage daemon, and you may have to restart it afterwards. So essentially, you try to avoid restarting storage daemons. You usually go for a configuration that can remain stable and static for a long time, and do all the fine tuning on the director side, where you can reload the configuration while the director is running. That sort of approach we think is reasonable because, well, the storage daemon is responsible for presenting storage or for using storage, and this underlying storage systems, whatever it is, be it tapes or disk systems, they usually do not change a lot. They also remain static, stable. So we decided it would not be necessary to have a flexibly restartable or reconfigurable storage daemon. On the other side, of course, for the director, where we think you will be working on the configuration, you will change that, you will adapt it to growing environments or to changing requirements. Of course, we need to be able to change configuration without stopping every job first. And that is the reason why we have this facility on the director side. For the storage daemon, that's not possible. So our recommendation is that for the storage daemon, globally, you set a pretty high maximum. Most of the time, I think that will be much more than 20. Just make sure that that you have some limit here. And that limit is actually covering everything you want to happen in practice. So, for example, if you have a few tape drives and a big disk-based storage system, hundreds of clients you need to back up, and you are pretty sure that you can handle the throughput for, let's just make up some numbers here, the throughput for 50 jobs at the same time. I would recommend to set a maximum concurrent jobs number on the storage daemon global end, perhaps to 200, which is much above what you expect to see. But the applied limits can be controlled on the director side and per device in the storage daemon, which is what we will be looking at soon anyway. And you can just be sure that you don't have to touch this very often, but it will be there to avoid resource starvation problems. So this is the most important advice here, I think, for this particular setting. The effective limits should be set on the director side. So we have some more options for the storage daemon globally. One of them is, of course, about the encryption of the transport data streams. We do that by default using the pre-shared keys, transport level security with pre-shared keys, or so-called anonymous TLS is what we use by default in the Bacula versions in the past few years. Data encryption actually would usually happen on the file daemon. That is something Alexander has mentioned, that we can do that. Actually, with the most recent versions of Bacula, we can also do data encryption, or as we call it, volume encryption on the storage daemon side, but we are not covering that here in this course. But what we do also not look into is that we can configure the storage daemon just as we can configure all the other Bacula components to do the TLS with the certificates, not using pre-shared keys to do the encryption, but using proper X509 certificates, which can give a bit better security. It gives you better control over things, and it has the drawback that you need those certificates and keys. It adds a lot of management overhead, and it will only be useful if you actually have access to your own CA internally, because well, commercially purchasing certificates for all of your backup systems may be a bit over the top. So, and then the other thing is that we will not look into how to run IPv6 as a network stack, for which purpose you would need the SD addresses sub-resource, which is what I referred to earlier, which gives you much more flexibility to control which addresses and ports are used by the respective daemons. And of course, here it's about the storage daemon. So we have the same set of resources, also, or directives, sorry, for the file daemon and director as well, of course. So this is just the high level overview of the storage daemon configuration, or if you will, the global storage daemon configuration. And of course, we are not interested in that in particular. What we are interested in is using storage devices. This is where we store data, where we read data from when we need to restore data. So those things are what needs the interesting part of the configuration. I mentioned earlier, or Alexander mentioned earlier, that a storage daemon can handle more than one device. It can also run more than one device type. All of them having different requirements. Some of them needing a particular configuration. So that is the reason why those devices can be pretty complex to configure. There are lots of settings for devices. A good number of them is what we will look at. Here we have an example, or rather an overview of what we need or what we can configure for devices. Of course, they all start with the device resource type, the braces as usual, and then we have some directives which you surely expect by now. The things need a name. We have not listed here. We have We have also the optional maximum concurrent job setting, of course, per device, not in this overview here. And we have all sorts of other settings. Some of them obviously referring to particular pieces of hardware or particular ways to operate those things, such as auto changers. Some of them pretty obviously referring to what we are actually configuring, device types, and some of them configuring how we treat them, how we handle them with Bacula. All of them we will have a look into. Let's first have a look at very particular settings for specific device types. In this case, for example, if you're running tape systems, you probably want to make sure that those tape systems are in good health. Tape systems need cleaning occasionally. They may need maintenance. Essentially, they suffer from what every physically used piece of appliance has. They are worn out after a time. They get dirty, so they need proper maintenance. To understand and to know what to do when. However, they have self-monitoring features built into them. Sorry. And we can query them. This is not anything that is very specific to the Bacula software. We make use of the facilities of the underlying infrastructure. And that is particularly well defined actually for tape systems. There are particular protocols specified with the SCSI layer of the protocols used to talk to them. All of that is in there. You can query them using specific programs, and you can hook Bacula up to those programs. So essentially what we can do is we can configure what we call the alert command, which gets one of those name strings, which in turn gets translated after percent encoded variable expansion to a program to be run with typically some specific arguments. And such program can then return a state of the tape system or the tape drive that we are interested in, which we can then use to control what Bacula or the storage daemon does with that. One of the simple things is we can make sure that all the output from the alert command ends up in job reports. So you have a chance to actually see it and to handle accordingly. We can also, and this is very specific to tape drives, I would say. We can also determine if a tape drive is in a state that makes it unreliable and will then automatically disable it for use with Bacula, which in turn usually leads to you being able to start the necessary maintenance process, whatever it is. Could be just a tape cleaning process, could be a replacement of the drive where you start by calling the vendor. All of those things essentially are things we can ensure that Bacula is aware of that state, and Bacula keeps its virtual fingers off of the tape, so you can actually do the maintenance without interfering. It is also possible to use the alert command to do other things as well. I mean, the title of this slide is tape health monitoring because this is what it was originally invented and intended for. But of course, you could do other things here. You can have an alert command that checks the status of your disk-based storage system, of course, in a very similar manner. Although those things are usually essentially built in a way to support different and in a way online maintenance processes. So the need for those integration facilities is a bit different here for different storage systems, I think. Well, we have an example here on the slide of what sort of information you can get from a tape drive, and if you are actually using tapes as a backup target, it may be interesting to review that or to be aware of what sort of information you get. Here we have well, we can determine that this is made up information, fake information, because we have over the lifetime of a tape drive, we have exactly 0 bytes moved and checked and error corrected, and of course that is not something you would ever see. As with all existing storage technology today, there will always be internal error correction cases, and you will usually, even if you purchase new hardware, you will see that it has been moving some data in between, just as part of the vendor QA process, for example. So even if you purchase a new tape drive, you will usually see that they already moved some data. And you will usually also, and that is the important thing, whatever you do, you will be seeing those counters for the error correction and rereads and rewrites slowly increasing. Those numbers will usually not be 0, but they should be reasonably low, whatever reasonably is, and they should not be increasing very fast. The thing you do not want to see, of course, is that you have uncorrected errors. So okay, it may happen. It's real life physical systems, so errors do happen. But in particular, those numbers for uncorrected errors, they should not be increasing fast. Just as a tiny bit of a hint, you could actually, of course, check those things manually, and the hardware that you are using is usually doing this sort of error tracking internally, and it's important to have a look at those things occasionally. So this was a slight digression into the direction of tape systems, which we do see very often with our backup application, of course. We will come back to more tape specifics in a while, but let's first look at those things that are well, generically available and can be useful for other storage media as well. One of those things that we need to control, in particular when we have tape auto changers again, but not strictly required only for them, but for other use cases as well, is that we may have devices configured that we do not want to automatically select for backup jobs, for everything happening automatically, just because we might be in a situation where we need to have a device ready for restores. And of course, restores are what is most important. Backups are, of course, the foundation to be able to restore. But if you are running in an environment, or if you are maintaining an environment, setting up an IT system where the strict requirement is that you can always immediately start restoring data, you may just want to make sure that you always have a device available for that. And if your devices are limited in their number because they are backed by physical systems, which you cannot just configure to be there, you have to purchase them first. You actually need to make sure that Bacula keeps one of those devices available, or several of them, depending on requirements, of course. To do that, we have the per device setting auto select equals no. The default, of course, is yes for us, but that means a device configured with the yes here can only be used if you explicitly reference it. It will not be chosen automatically just because it is part of an auto changer. So this is the sort of setting you want to do if you have a limited number of tape drives in your tape library. Let's say you have 4 tape drives and you want to have one readily available for restores at all times. You would just be putting auto select equals no for one of those tape drives. Whenever the director and storage daemon start a job and need a drive from the tape library, they can pick any of the other 3 to do whatever is necessary, but the one with auto select equals no can only be used if you explicitly reference it when you start a job. So not just pointing at the tape library, but pointing at one particular drive. So you can have that mostly for restore jobs. You can, of course, also configure highly important jobs to use one particular tape drive for their backups, but that would be rather uncommon. It is very useful to do that, and you can also, and this is where we get away from the tape systems. You can also use this setting with disk-based storage devices in Bacula, which you can also group in auto changer. We usually call those virtual auto changers or disk changers, where we can just use the auto changer facility to group things together. To avoid, in a way, the micromanagement of individual configured devices. You just create a few devices and have them ready. And in those cases, you might also want to have spare devices for urgent jobs or restores. Restores, by definition, are urgent jobs, I think. And so it is reasonable to have auto select equals no also for non-tape devices that you are configuring with Bacula. We can have a look at examples a bit later, I think. Well, and then again about grouping things in auto changers, and here about physical systems, tape libraries in particular. Again, we have some wait times we may have to configure, because essentially what happens when we do change tapes and load tapes in a tape drive, well, physical stuff has to be moved. And that takes time. It does not happen immediately. So on the one hand side, we need to wait. When we change a tape cartridge in a tape library, we know we need to wait until the tape hardware the tape drive has released a tape cartridge. The tape library picker has picked up the tape cartridge, has put it into its storage slot, has moved somewhere else, picked a new cartridge, moved it to the tape drive, put it into the drive, and all those things, of course, take time. We need to wait, but again, we need to make sure that we are not waiting infinitely long if something goes wrong. Because if something goes wrong, we want to be able to do something else, or we want at least to notify an operator that there is something where intervention is needed. So we need to be able to determine what is the regular expected wait time. And that is what we configure here, the maximum changer wait time, where we have a default of 5 minutes, which means when Bacula starts changing volumes, we will wait for a maximum time of 5 minutes. If that time is exceeded and the media change has not succeeded, then we consider something went wrong and ask for help. The actual time here may need adjustment. 5 minutes is usually fine for small libraries that you are using exclusively with one Bacula instance. It may be too short for really large tape libraries. And it may be too short in particular when the tape library is shared with other applications or other Bacula instances, which might happen in the situation where you have a tape library that is partitioned, as it is called, where essentially the tape library is configured to appear to be, well, more than one tape library, but they are all sharing in particular the same media movement mechanism. So when one application working with one partition of the library is doing stuff, everything else has to wait, of course. And for really big tape libraries, 5 minutes is, big tape libraries are usually fast, but they are also very often shared between applications. And sometimes you actually have a situation where you have one tape library where you have just one media movement mechanism or one picker, and it occasionally has to move really long ways. So those 5 minutes can be short in either cases. In that case, feel free to change this setting to increase it to whatever works for you. If you need more than, well, if you need change times you cannot reasonably express in minutes anymore, it's probably time to check if something is wrong with your tape hardware, though. We have other wait times. Those are related mostly to actual tape drives, not so much tape libraries, and not necessarily different media types or device types. Well, rewinding a tape, again, that needs some time. Sometimes it might go wrong, and then we need to notice. 5 minutes rewind time we found that to be reasonable in practice. With today's tape hardware, that will usually be sufficient. It can be a bit long, in particular if you are working with really worn out media, which you should not be doing, but sometimes it's not your choice what you use. Sometimes you have to use what is there. And in those cases, an increased rewind time may be useful to avoid spurious error messages. And the open wait time is kind of the opposite. That's the time we need to wait when a tape has been put into the drive before it can actually be used by the tape drive. That is again something that is pretty much depending on the technology, on the hardware used. And again, we have seen cases where the default of 5 minutes was not sufficient. And again, that usually happens with really worn out media, which with today's tape systems, you should not be seeing because, well, okay, I mean, you can wear out tapes, you can really use them up. And that is something that will necessarily happen to some extent. Those things are really put under a lot of strain when they are being used. But today's tape technology actually has counters that are part of every tape cartridge, where the tape cartridge and the tape drives, they count how often they have been loaded and been used, and they will eventually refuse to write more data to a tape that is getting close to be worn out. So you would not be seeing that in practice with decent hardware today. But again, sometimes you do have old hardware which you have to handle, and then it may be interesting. So maximum open wait time, you should only need to change that if you are not using LTO, current storage tech, or IBM media. So, and then we have another thing, and this is to keep the device we are using always open. Well, sounds very particular. And again, this is something that is really specific to tape systems again. For file-based storage, of course, the logical write position is always managed by the operating system, should be reliably tracked, and in particular, it should not be anything you need to care about, because seeking in a file to find the position you want to write to is something which happens more or less instantaneously. It's really something that the file system and the file system layer of the operating system can do very quickly. So nothing to really be worried about. With tapes, of course, it is different because the write position of a tape is always, by definition, by the nature of those sequential access media, it's always at the end of the data on tape. And getting to the end of the data on tape, of course, implies that we have to move the long tape until we reach that position. So moving there can take a long time. Essentially, it's more like the rewinding time and open wait times that we may need. So we're talking really about several minutes, and sometimes about quite a number of minutes that we need to wait until we can reach the position to write a tape to. And that, of course, in practice, leads us to try to operate with tapes in a way that once we have finished a job writing to a tape, we simply wait at that time. We leave the tape idle, loaded in the tape drive, positioned where we need to be, so that a future job can immediately pick up writing. While in practice, it means rewinding a bit and then picking up speed until we reach the proper write position and then writing. But that's just a few seconds instead of rewinding the complete tape and then forwarding to the end of tape again. So this is what we get with the always open equals yes setting, which is the default. There is, however, a very specific risk here, and that is that the tape could be repositioned without the tape drive noticing, or the tape drive telling the operating system, and the operating system in turn notifying the application software, the bacula software of that. If you are concerned that that might happen, the solution is to put always open equals no, which will then tell the storage daemon that when it has finished writing a job to the particular device we're configuring here, the tape gets rewound. It actually gets closed, which is the logical release operation for the operating system. And the result is that when we start writing the next job, we have to open the device again, and we have to reposition to the proper position of the tape. Again, this will take a comparatively long time, but it is the only way we can actually guarantee that we know at which position on the tape we are, which is implying that this is something you only do if you are somewhat paranoid. Of course, we are somewhat paranoid, otherwise we wouldn't be doing backups in the first place. And unfortunately, it turns out that there are certain situations where this is really needed. Of course, we trust that the necessary storage hardware we use to be reliable, and we trust it to act in the way that that it is supposed to do. But it is sometimes possible that you achieve a situation where actually a tape gets repositioned without the bacula software knowing. And of course, this is not something you would be doing intentionally, but there are, I would say, 3 situations where that might happen. One situation is actually manual intervention. If you end up with a situation where you can physically remove the tape from the tape drive while it is still in use or opened. I mean, we're not writing or reading, but we have it open at the application layer, at the operating stack, operating system stacks. And you just do a forcibly eject of a tape, and then reinsert that tape. It will in between be rewound, and it will be inserted, and it will be positioned at the beginning of tape and not at the end of the tape. And depending on the essentially on the tape drive, its firmware, potentially its configuration, potentially the HBA, the SCSI or fiber channel adapter used, and whatever, the operating system may not be notified of that relocation of the tape. And we would then trust that we are at the end of tape, happily write new data and overwrite what is already on the tape. And of course, this is not desirable. It shouldn't happen because it would really be something you need to do manually, very explicitly, kind of intentionally breaking things. So probably not the most likely thing to happen. Another reason, which is very similar, is essentially power failure for tapes. When tape drives power up, they usually rewind whatever is inside and reposition to the beginning of the tape, because that is the only reliably accessible position in that sort of situation. In that case, the tape drive should be sending a notification to its HBA and whatever, but sometimes that does not work. That is a situation that we have seen in practice, or actually that customers of ours have seen. And of course, the third situation is essentially firmware problems with tapes, tape libraries, and HBAs, which are occasionally happening. And it turns out that it happens much more often than you liked. Very often it appears that if you purchase new hardware, you get them shipped with really outdated firmware. And very often we have had reports that people deployed new tape systems and they were totally unreliably behaving. So they ended up being very careful, like setting always open equals no, until they eventually got around to notice that the firmware update fixed a lot of their problems. So, and very closely related to those things, firmware problems, of course, all of those things eventually lead to resets of parts of the hardware, and that can also happen if you have power problems. In a data center, of course, we all trust that you have reliable power supply, redundant power supplies with redundant, independent, uninterruptible power supplies and emergency generators available. In theory, we have that. In practice, we know it doesn't always work that way. So if you know that, for example, in your data center, the host that runs the storage daemon is operated with a UPS, but the tape library is not, and you just want to be on the safe side, it might be reasonable to consider setting always open equals no. We would consider this a workaround for a problem you should be solving in a different way. But we have to have that workaround because we know that sometimes those problems cannot be solved quickly or easily or reliably. You should find that you do not need this setting for any other storage device type, but tape systems, by the way, because all the other ones are essentially at the first tier always treated as files by Bacula. Well, and files are managed by file systems, and we have at least part of the file system software stack right on the host next to the storage daemon, and it's usually very, very reliable. So the risk of having problems there, which are related to keeping devices open while they are actually idle, is well, I think can be ignored. So that was about some aspects of the actual storage hardware. Now we need to consider some aspects of the actual storage media. Also, of course, very often hardware in some way. Alexander mentioned that Bacula by default treats all its storage volumes just as tapes in the way that we write sequentially to them, just appending data. We reach a point where we consider them full, and then we stop writing to them and until we can start recycling, start reusing them from the beginning. Now, for tapes, that's perfectly fine because first of all, usually you expect to really fill the tapes, which is nice because it makes the thing cost effective. The advantage with tapes is they have a built-in end of media because they have a physical media, which has an end, of course. So we know exactly when to notice a media is full because we will get notified about that. If we use file-backed storage, well, plain files or files that are eventually shipped to cloud storage, for example, or that are represented as specific deduplication engine entries, stuff like that. Whenever we back up to to files, we have only one built-in end of volume or end of media indicator, and that is when the file system is full. Which is, of course, not what we want to do because a really filled file system is first, of course, usually a pain to manage. Things get slow, things get occasionally even unreliable if you have no free blocks in the file system. And you definitely do not want to do this, particularly with the file system you run your operating system on. And secondly, the way we treat volumes means that you have a problem freeing up space at that time because we would only be freeing up the complete volume, which means we are essentially losing everything we already have stored in a volume. If we end up with the situation that we have just one Bacula volume in your complete storage pool, one gigantic volume, we cannot keep data if we want to go on doing backups. Because we recycle the capacity we used with the granularity of volumes or files in that respect. So we need to make sure we use more than one volume. We need to force the storage daemon to detect or to consider a file-based volume to be full, so that we can force Bacula to create new ones, to have granularity with the storage usage. And that is done by setting some sort of limit to how much data can be put into a volume. Well, Alexander mentioned that with the pools, we have ways to do that: maximum volume size, maximum use times, for example, maximum number of jobs. Here we see one setting where we can do that on the storage daemon side for the device. The device doesn't know about use times. It doesn't know about even jobs. It just knows about data it puts in there. So we have a last resort setting for the device entries, for the device resources in the storage daemon configuration, which is the maximum volume size setting, which by default is set to 0, which means unlimited. But you can put a number here, and that would then be the number of bytes we can put into volumes for this particular storage device. It is most useful to do this with disk-backed volumes, as I mentioned, because those are not having a built-in end of media indicator. You should usually try to specify those things in the director's pool resource, because that gives you better control. But it is potentially interesting to, again, have some sort of last resort, prevent any sort of disaster setting here. So if you have hundreds of terabytes of storage capacity, for example, and you have set your pools so that you create volumes of, well, a few gigabytes of size, perhaps tens of gigabytes of size, it might be reasonable to have a maximum volume size here of some 100 terabytes. Just so you have a built-in limit if you forgot something, or if something turns out to be not working the way it is intended. And you can later on at least make sure that you are not filling your complete storage pool. And you will also be able to notice which volumes need attention, because, for example, if I configure my regular volume sizes to be 50 gigabytes in size, and I have here the last resort setting of, let's say, 200 terabytes, 200 gigabytes, sorry, in size. For example, that would mean I can easily detect those volumes where something went wrong by just looking at the directory listing. So it is a matter of, again, care, paranoia in a certain way, putting last resort limits somewhere, and still making sure that you notice when those last resort limits have been applied. You can do that here at the storage daemons configuration, device resources. Well, for disk storage systems. For tapes in particular, we have a maximum file size setting, which has nothing to do with the size of files we're backing up, not the user files that we're backing up. This is the very particular terminology used with tape technology again, where essentially we just have markers we can put on tape. And those markers are the positions on tape a tape drive can reasonably quickly move to. It is by tradition called a file marker, an end of file mark. And those things are needed on tapes, well, first for management reasons, because we can quickly position to them. We need them because, well, we also count tape positions using them. And we keep, in particular in the catalog database, with each end of file mark, we create a catalog resource, catalog entry. So we keep track of where those data is, and we use that when restoring. Giving us essentially the granularity for quick positioning to the data when we restore. So again, keep in mind, this has nothing to do with the actual data you put there. It's just logical positioning data. But you may want to position to balance that reasonably. If you have large logical tape files, well, you make better use of your tape capacity, because each of those things needs a tiny bit of tape capacity. It actually needs a bit of time when writing. So if you want to reduce the overhead of stuff put on your tapes, you will go for very large file sizes. You will have a high number of bytes between those file marks. But that will mean that if you are restoring, we need to skip a bit more data than what we really need to restore. If we try to avoid that and to be able to have fine granularity when positioning to tapes positions when restoring, then you want reasonably small file sizes. So you can change that according to your requirements. The big question usually is, what is a good value here? And of course, there's not one single good value, but we have recommendations. For old tape technologies, you would go for smaller numbers, of course, because the tapes are smaller in capacity anyway. For new ones, up to date tape systems, you would go for larger numbers. And for example, for these, we haven't put LTO9 here, for example, but it's similar in capacity and speed to the IBM Jaguar drives. So for LTO8 or 9, probably you would be going for 16 gigs or even 32 gigs of maximum file size. You can change those settings during the lifetime of a bacula instance. It won't be doing any harm because the correlation will always be what is actually written on tape and on the tape cartridge. So no problem to change that when you now consider that you may want to touch that. The most interesting observation here, I think, from my point of view, is that the default that we have of 1 gigabyte is for today's tape hardware too small in reality. You're just wasting capacity and time writing to tapes. You will probably want to increase that. And by the way, we are going to point out that we have a test program which helps you finding reasonable values. We will look into that later. Right now, before I go into the spooling specifics for tapes, and we have more settings for devices, which I'm also going to mention, we are going to have a short break of a few minutes so we can all get fresh drinks or whatever, have a short breathing room. I will try to do the same thing Alexander does with the annotations on the slide. I'm not very good with that. While I do that, do you have any questions up to this point? No questions? Okay, so it's nearly 10 minutes past the hour. So I think Alexander went for 10-minute breaks usually. So until 20 minutes past the hour.